Yeah, first setting up the modules like importing pandas and NLTK. So here I imported two modules, pandas and NLTK, and also sentence tokenize and word tokenize. And you don't have the default popular, so we have downloaded the NLTK download popular here. Next, taking the raw data from the this link source. We are reading the data we have taken through the pandas read CSV, and we are here. We don't need the ID column, so I'm deleting the ID column, and then I'm printing the data using data.head, filtering out the null values using this null function here. And next I'm reading the pandas data using the pd dot series. And next I'm using the sentence tokenize to make the sentence the tweets that we taken from the on text raw data. I have used the sentence tokenize function for this. And then next I use the word tokenize uh, to, to to make the words in a list. Below we have was 606 words. And then next I imported the regular expression tokenizer from NLTK tokenize. So from the I imported regular expression tokenizer function. Then this is the result. Next, are you using the frequency distribution? We can able to see the most common words, and we can plot the most frequent words in a graph. So this is the graph. And next, I'm eliminating the punctuations and numbers by using the is alpha function in the for loop. So below is the result. And the next, and use the frequency distribution. From this we can see the most frequent elements repeated after eliminating the punctuations here. This is the graph. And next words, removing the stop words using the stop importing the stop words module. So here I use the function stop words dot words of English. Next, this is the function I have taken to filter the stop words and remove from the words we have to get from the after tokenizing. The next, clean letters. This is the clean letters total we get after removing the stop words. So the I have used the pandas data frame here. The next, here I building the we build the old cloud by taking the image from the internet. So here I imported the word cloud image color generator request image text blob. uh, this is the function, this is the link, and below you can see the date. We can see the data that was fit into the image we have taken. And next I stemming the next we did the stemming by importing the Porter stemmer. And the next and also the we did snowball stemmer by importing the snowball stemmer module. Next, lemmatization by importing the WordNet lemmatizer. Next, this is the post tagging. Here I used the function, we use the function nlticket.post tag, and below is the result. We can get the parts of speech like noun, verb in the tuple format. Next, getting the bag of words by using the count vectorization. Uh, Below I tokenized the sentence for the count vectorizer. So here for this I imported the module from scale and feature extraction test, import count vectorizer. This is below is the result. And then performing the TF-IDE of vectorization on data, and here, from here onwards I'm splitting the data and understand the class distribution of positives and negatives. So here we are splitting the data to positive tweets and negative tweets that we have taken from the internet. So for this I imported the module train test split and TF-IDE of vectorizer. This is the code, and here splitting the data for the building the module. Xtrain xtext, ytrain ytext are taken, and here I've taken the smooth function, smooth module, to address the class imbalance problem for the text for the both positive and negative. Like after this, finally when we have it, we count, we get the total, like how many positive and negative. Building the here we are building for building the model, we have to install the cat boost package. So I install the pip install cat boost. After this I imported the libraries that are required for model building. These are the libraries, and uh, we defined the function to fit the data. So we have taken our customized function like build modules. You can take custom function, and then next we initiate the models with the parameters and creating a list of models to pass through the above created function. So we below pass it the all the models that we have created, and this is the result. This is the final result accuracy after printing. This is going to iterating the all the modules. This currently running still. This is providing the data. Below is the data you can see.